Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 7-segment display interface with 8051 microcontroller. So look at this. This is the 7-segment display. So each one will be a single LED will be considered. Look at this. So this is the 7-segment display. So look at this: A, B, C, D, E, F, G, and this is dot point. So each one will be considered as a single LEDs. So we can turn on or turn off these LEDs to display the informations. So 7 segments plus 1 dot point. So totally we have 8 displays. So this 7-segment display will be most useful for displaying the numbers from 0 to 9 and the characters A, B, C, D, F. So the only limited characters will be possible to display using this 7-segment displays. So this will be used in clocks, counters, electronic meters and display units. So this will be interfaced with microcontrollers for displaying the information. So look at this. Each one we have, this is the common point. Look at this. This is the common point. We have 2 common points and we have the segments. So totally we have a 7 segment plus 1 dot point. So that's why look at this: A, B. We have this C, D, E, F, G, and this is dot point. So each one will be treated as an LED. So we can turn on and turn off LED to display the particular information. So this will be most useful for an user interface. Because whenever you are displaying information in binary form, the user cannot understand. So user knows only the decimal format. That's why we use this 7-segment display for displaying the decimal informations. Look at this. We have 2 types of 7-segment displays. I already told you it is considered as an LED. So instead of controlling both the anode and cathode, we can control any one and another will be connected to the supply. So that is the basic format. So we have 2 types. One will be common cathode and another will be common anode. Look at this. So this is common cathode and this is common anode. The difference is the terminals. So here each one will be considered as an LED, no? So LED have 2 terminals. So one will be anode and another will be cathode. So in common cathode, all the cathode terminals of the LEDs will be connected and that will be connected to ground. So only thing we need to give an anode supply to turn on a LEDs. So in common anode, all the anodes of the LEDs will be connected and that will be connected to VCC. So once if we give a supply for a cathode, the LED will be closed. So depending upon the common cathode or common anode, we need to give a logic 1 or logic 0 to turn on the LEDs. How it will be? Look at this. So this is the common cathode. I already told that all the cathodes will be connected and that will be connected to ground terminal. So only thing we need to give a anode supply. For a anode supply, we need to give a VCC. So wherever we give a logic 1 to the segments, that LEDs will be turned on. For example, if I give 1 to this A, this LED will be closed. If I give 1 to this B, so this LED will close. So similarly, what are the LEDs to be turned on? We need to give a logic 1. In common anode, just opposite. Already anode is connected and that will be connected to VCC. Only we are going to give a cathode supply. So what are the LEDs to be turned on? I need to give a logic 0. For example, I want to turn on a B and C. I need to give 0 for B and C. And if you want to turn off these things, we need to give 1. Just opposite. Look at the arrangements. So this is a common anode arrangement. This is common cathode arrangement. Look at this. Here anode, no, all the LEDs, all 8 LEDs, anode will be connected and that will be taken here. So this will be connected to supply. So wherever we give a zeros to this LED, that LED will be closed. Similarly, look at this common cathode method. The LEDs, all cathode terminals will be interconnected and that will be connected to the ground terminal. So wherever we give a logic 1, that LED will be closed. So here, wherever we give a zeros, that LED will be turned on. Here, wherever we give a logic 1, that LEDs will be turned on. This is the difference between common anode and common cathode. Look at this, how the data will be formed. See, look at this. I am going to display the information 0. So 0 means this is 0. That means this G and this dot point no need to display. Remaining all segments to be turned on. How? Look at this. Look at this. I am giving 1 to this dot point and G also 1. Remaining all I am giving zeros. So here 0, 0, 0, 0, 0. What happens? These LEDs will be turned on and these 2 LEDs will be off. So what it displays? It displays a 0. Similarly, for example, I want to 1. So 1 means BC is to be turned on, remaining all should be turned off. So look at this. For a B and C. So this is C and this is B, no? So this is C and this is B. I am giving zeros, remaining all I am giving 1. So what happens? Only this BC terminal will be on and remaining will be off. So here we have a forming a from 0 to 9 the lookup table for this. So this is the binary data. I am converting this binary data to hexadecimal for easy storage. Look at this, how this will be working. Look at this. Which data I am giving, that values will be here. So 0 means logic 0, 1 means logic 1. So that corresponding information is displaying here. So look at this. So 1, 2, 3, 4, 5, 6. So what are the LEDs to be on? I need to give that value. And what are the LEDs to be on? I need to give a value for this. So this is common anode. Wherever I give them 0, that LED will be closed. Because already common anode VCC is connected. Look at this. This VCC already connected. So wherever I give zeros, that segment LEDs will be turned on. Look at the circuit diagram. So this is the microcontroller. I am taking 8 segments from an port 2 and I am connecting it to the 7 segment display. Look at the program. So I am taking the unsigned character, all the lookup table data. So we have a 0 to 9, the total 10 data. I am taking this from that lookup table. So 0x indicates a hexadecimal data. I am taking an integer k. This is for looping. So while 1 always it will be executes. So for k is equal to 0, k less than 10, k plus plus. So it will be execute for 10 times. So port 2 equal to no code of k. That means, so this is the no code actually array variable name. So k I am taking this. So what happens? No code of 0, 1, 2, 3. So that means, so C0 will be sent to port 2 and then C1, C2. So like that. So each data will be sent to this port 2. So I am taking a delay 100 milliseconds. So the required amount of requirement, it depends on that we can take a delays. So what happens? It displays a 0, then 1 and then 2, like that it displays. After completing all the data, again it starts from 0, it displays the information. Thank you.